Hello again, welcome to the second module of our review for Calculus 1. This one will be dealing with operations on polynomials. So what's a polynomial? It's an expression like something times x plus something times x, and generally speaking you could actually call it a index n times x to the power of n plus a index n minus 1 times x to the n minus 1 power, and so on and so forth. So in simple terms, something like 2x 4 minus x squared plus x minus 11, that is a polynomial. And this polynomial has a degree of 4 because 4 is the highest exponent in the expression. That's what we call the degree. So in this section, and in calculus in general, we'll have to deal with operations dealing with polynomials. So let's start with addition, subtraction. So basically, what's involved in here is to combine what's called like terms. Like terms are the same variables with the same exponents. So for something like we have here, what we want to do is remove the brackets by simply changing the signs of all the terms in the second bracket, because it actually has a minus in front of it. So that becomes minus xy squared minus 2x3y and plus xy. Now to simplify this, we look for like terms. Are there any other x3y terms in this expression? And yes, there are. So these two are like terms because it's the same variable affected by the same power. So 4 minus 2 is simply 2x3y. What else do we have in terms of like terms? Well, we have some xy squared and xy squared. So 2 minus 1 is just 1xy squared. The other terms are not similar, so we will simply rewrite them, and that will constitute our final answer. Simple enough, yes? Okay, now let's take a look at some other operations, like multiplication. So what we do when we want to multiply two polynomials together is we do the old FOIL thingy. So 2a times the first term, 2a times the second, 2a times the third, and when we're done, we're going to go minus b times the first, minus b times the second, minus b times the third. So let's start with the 2a. Let's distribute this over each element of the second bracket. 2a times a squared b, that's 2a 3b. 2a times minus 3ab squared is minus 6a squared b squared. And 2a times 9b cubed is plus 18ab3. Now we do the same with the second term of the first bracket with the minus b. So minus b times a squared b is minus a squared b squared. Minus b times minus 3ab squared is plus 3ab3. Finally, minus b times 9b cubed is minus 9b to the power of 4. Looking for like terms. I see minus 6 a2b2 minus 1 a2b2. That would be minus 7 a2b2. Also have 18 ab3 plus 3 ab3, that would be 21 ab cubed. And the other terms are not similar, so plus 2a3b minus 9b to the 4 makes up my final answer. Simple enough. What about raising a polynomial to a certain power? This is again something we'll meet often in Cal 1. So how do I expand, collect, simplify x plus h to the power of 3? Well, we simply write the power of 3 as the expression times itself 3 times. And we're going to start by multiplying x plus h with x plus h. And we'll keep the last round bracket for later. So, x times x, x times h times x, h times h. What we got here is x squared plus 2xh plus h squared times x plus h. And here we go again, the FOIL thingy. So x squared times the first, x squared times the second. The middle term, 2xh, times the x, that's 2x squared h. Now 2xh times h is 2xh squared. Finally, h squared times x is xh squared, and h squared times h is h cubed. I should have quite a few like terms, namely x squared h here, and x squared h here, and xh squared and xh squared. Let us collect these together. That will be 3. X squared h, that will be also 3. Xh squared and plus h cubed gives me the full expansion of x plus h to the power of 3. Lovely. One last operation. Division. Okay. How do we divide here? Well, that's the process known in high school as long division. And here we're going to have to be considering 2 different approaches, because most of you come from English high schools, but many of you have learned this français. And although the mechanics of it is the same, the way to write it is quite different. So let's take a look. How would the English student write this? They would put it this way. x4 minus 2x3 plus 4x minus 5. That would be the way this long division begins. While in the French sector, what you've seen is something written slightly differently. They would actually write it this way, and then x squared plus 1. Obviously, like I said, it's the same procedure, but the procedure is written differently. So, how does that begin? Pretty simple, but before we begin, one little remark. Notice here that I have left a little bit of an empty space between the x squared and the 1. That's because we have here 0x. And I did the same thing here. We don't have an x squared term in the numerator. So we're going to have to leave an empty spot for that. Same thing here, of course. And here, bien sûr. And you'll see why this is actually important in a minute. So how does this begin? It's always the same thing. First term divided by first term. So first term divided by first term. The answer to that is x squared. And we're going to put it here. And now what do? We take that x squared and we multiply it by the 2 terms that are here. X squared times x squared is x4. X squared times 1 is, x squared, which I will line up with the 0x squared right above it. So subtracting, I get the x4's cancel. That's minus 2x3. Now 0 minus x squared, that's minus x squared. And as you may remember, we bring down the next term and we are ready for the second step. Now let's do the same thing on the French side. x4 divisé par x2 is x2. We put it under instead of putting it over, but of course it's the same thing. This time we do x squared times x squared and x squared times 1. So x4 plus x squared. We subtract and get minus 2x3 minus x squared. Bring down the 4x, and we are ready to roll again. So let's switch back to English. First term divided by first term, so minus 2x3 divided by x2. The answer is minus 2x. We put it here and we multiply. So minus 2x times x2 is minus 2x3. Minus 2x times 1 is minus 2x. Again, I line up my powers on the same column and I subtract. Minus 2x3 minus 2x3 say gone, so minus x squared, and that's going to be 4 minus 2, so that is 6x. Bring down the negative 5, and since there's nothing else to be brought down, I know that I'm down to my last iteration in this procedure. Let's do the same thing on the French side. So what do we have here? We have minus 2x3, which is the first term here, divided by x2. Answer minus 2x goes here. Multiplication minus 2x3 minus 2x. Subtract. It will come to no surprise that we get the same thing as what we've already done on the English side. So bring down the minus 5. Like I said, there's nothing else to be brought down anymore, which means we're almost over. So let's do one more iteration. First term divided by first term. The answer is minus 1. We put it here and we multiply by x squared plus 1. So minus 1 times x squared is minus x squared, and minus 1 times plus 1 is minus 1. Subtract. Get 6x minus 5. Minus 1 is plus 1. That's minus 4. Like we said, nothing else to be brought down. You may recall that this is called the remainder. On the other side, for one last iteration, minus x squared divided by x squared. This is minus 1, goes under here. So minus x squared minus 1. We subtract. Of course, we get the same thing, and that is called le reste. So how do we write the outcome of this operation? Well, we could write it this way. x4 minus 2x3 plus 4x minus 5. We were asked to divide this by x squared plus 1. And we end up with something called a quotient. X squared minus 2x minus 1 plus the remainder 6x minus 4 divided by x squared plus 1. This is actually the outcome of the long division. So that's division for you. To conclude this little section, one summative example, something that is supposed to use more than one of the rules we've seen here. So we got this expression, how shall we begin? There's a square outside, so I suggest that we write this as x minus y squared, so times itself. X plus y again squared, so times itself. And here, let me take the minus 2 inside the bracket, so minus 2x squared minus 2y squared. So here we go. That's going to be x squared minus xy plus y squared. Same mechanics here. So x squared plus xy plus xy. Everything's positive in this one. And here is minus 2x squared minus 2y squared. Looking for like terms, looking for like terms. Look at that. X squared plus x squared is 2x squared. Minus 2x squared is bye-bye. It's gone. Y squared plus y squared, that's 2y squared. Minus 2y squared, goodbye. Minus xy plus xy minus xy plus xy. How do you like this nice simple answer? Which concludes this section on operations on polynomials. So hopefully this was a little bit useful, and I will see